Okay. Um, all right. So, composition of transformations. Um, we know our transformations are first one we talked about were translations, right? Okay. The second one I think we talked about were reflections. We've talked about rotations. And the last one was dilations. Okay. So those are the four that we've done. Now, sometimes what we're going to do right now is we're going to put these together. Sometimes they call this, like when I put those two together, they call them glide reflections. I don't ever use that word, but Math Excel does, and of course Exam might. But a glide reflection, because a translation sometimes called a slide, sometimes also called a glide, because glide means to move left and right kind of smoothly, right, or up and down, and then you get the obviously reflections. So we're going to start pairing these things up. Now, a lot of things they will do consistently, at least in Math Excel, is that those three get kind of composed together a lot. Occasionally they'll throw a dilation in, but my thought is that in your homework you might not see any compositions with dilations in them. They put those three together because those three are all the rigid motion ones. Those are all the isometries. A dilation is not, but you can still put in a dilation if you need to, if you want to. Okay. So even though you may predominantly see those three being the tasks that we go through in a little bit being used with those three, you can do it with all four. Okay. And you can even do it. We're gonna focus right now. If we're gonna use these two, we're gonna focus on doing it in respect to the origin because it just simplifies things a little bit. But we can still do it around any point that we want to. Okay. It just adds in another series of steps to kind of focus on, which we already know how to do them. What I want you to understand here is that you already know all of the foundational building blocks for being able to do this. You know all those transformations over there on the whiteboard, and I'll bring them up here in a moment as well. I think I sent an email to everybody here a little bit ago with the list of all of those in there. So if you don't want to write them down right now, you don't need to. But we're going to use all of those, okay, because those become pretty beneficial to us, okay? Is that doable? Okay. Don't like me saying, is that doable? Huh? Yes, you are supposed to reply with a then we'll talk about why. That's why I always ask, are we on the same page? Does that make sense? Is that doable? Because I want to know. If it's not, I need to do something else. I need to explain something in more detail. We need to have a conversation. Yes. Let's do that towards the end, though. All right. So composition of transformations. Okay. You're going to see some notation that is not maybe comfortable. Okay. We know that like a capital T means translation, right? And they're going to put just something down here in those spots. Okay. And that'll tell us how to translate it. Okay. You are then going to see an open dot. Okay. And then they're going to put another transformation. So maybe we do a rotation and let's just say 90 degrees. Okay. I'm just going to put like 2, 1 in here just to have values there. So you might see something like that, and they're going to say then that you want to do those transformations to some pre-image. Okay. So let's just say that my pre-image is maybe like triangle ABC. Okay. Now this open dot, it means phrase composed with. Okay? It is not multiplication. Okay? It is not a solid dot, it's an open dot. And we refer to it as the phrase composed with. So the way I read this is we're going to do transformation of 2 comma 1 composed with a 90-degree rotation of triangle ABC. Okay? Now, even though that's the notation, there's a little bit of discrepancy on how we got to read this, or confusion sometimes it occurs when we read this. We actually read this and conduct the transformations backwards. We're going to work from the right to the left. Okay? And this is going to be something that you guys see in Algebra 2. Okay? When you do a composition, in Algebra 2 you do composition of functions. When we do compositions, we can rewrite it this way. We can use a parenthesis notation. So I replace this open dot with a parenthesis. And then I'm going to rewrite all this stuff. So R90 of triangle ABC. And once I write all that stuff down, I close that open dot that had a parenthesis. You're going to like this notation more, I think. Okay? But this is a notation that's going to be provided probably most consistently. Okay? The reason you may like this one a little bit more is because order of operations are kind of consistent with how we would approach this. Order of operations, don't you always look at parentheses first? And if there's multiple parentheses, don't you go to the innermost set of parentheses? Okay? And then you start working your way out. So our innermost set of parentheses is our triangle ABC. That's just our image. So there's really nothing we can do with that. So then we start working our way out, and we get to this thing here. Does that kind of make sense? And that tells us that we're going to focus, and we're going to do this transformation first. And that transformation is going to turn into an image. So maybe that image we call a triangle A prime, B prime, C prime. Okay, so this whole set of parentheses turns into a new image. And then we're going to apply the remaining transformation to that. Does that kind of make sense? So you're going to start with a pre-image. You're going to get another, and you're going to do a transformation that's going to create an image. That image is now going to become a pre-image for another transformation. Okay? And then when we get that image, it may become a pre-image for a third transformation. Okay? Because we could do something like this. We could say, we're going to start with a reflection, let's just say, of the y-axis, followed by maybe a rotation of 90 degrees, maybe followed by a, I keep saying followed by, but that's not really the way we would do it, a translation of maybe 3 comma 1, okay, of some pre-image. I'm just going to call it A. Okay, so she's doing this to one point. The way we would probably rewrite that using this type of notation here is that you put a parenthesis really there, and eventually you have to close that off, and you put a parenthesis there, and eventually you have to close that off. And what that would look like so these two parentheses are the ones that would close those two first parentheses off. But now you can see that you work on your innermost parentheses, and that's just this point. That's your pre-image, okay? And now this notation tells us that we're going to do that to that point A. And that's going to turn into A prime, right? And once that turns into A prime, you now have the 90-degree rotation outside that. And then you have the reflection outside that. So now this yellow stuff turns into A prime, and now you can do a rotation of 90 degrees to A prime. So you would do that. And A prime, just kind of running out of room here, so I'm going to go up here. A prime would turn into A double prime, right? So this goes away, turns into A double prime, but you still have this final transformation on the outside, and now you would reflect A double prime across the line x equals 0. Does that make sense? Is that doable? All right. That's I think that's a great series of notation and a great exercise to kind of mess around with and look at to prove the point to you that we're just doing reflections, rotations, and translations, the same things we've been doing, but notation-wise, if you can't read the notation and you don't read the notation correctly, you're not going to get the problem. You're not even going to be able to start the problem. Does that make sense? Okay. So we are working. If we rewrite this way, we're working our way from the inside out. Okay, and that's what you always want to do with your nest. We call these nested parentheses. Okay, parentheses inside parentheses inside parentheses. If you leave it alone, because some people prefer not to touch it, and just leave it alone like I've got written over here. Okay, if you kind of draw a comparison to what we did here to how you're going to do it here, you're going to work on that one first with A, and then whatever that image becomes, you're going to do that one next, and whatever that image becomes, you're going to do that one too. So here you're working from the right to the left. Is that all right? Okay, if you don't want to rewrite things. That becomes problematic if you think about it that way in Algebra 2, because in Algebra 2 you're going to talk about functions. So, you know, for instance, in Algebra 2, you're going to have something that looks like this. F composed with G of X, where F might be like a function like 2x plus 1, and G might be a function like x squared. Okay? Well, if I write this as 2x plus 1 composed with x squared, okay, it's hard to realize what I'm trying to do here. But if I write it this way, f of g of x, it just basically means that I'm going to take that g of x, which is x squared. Come on. And I replace that g of x with what it was equal to, x squared. And now, inside f, wherever I see my input value of x, I'm going to replace it with x squared. So this is going to, the answer, f of g of x becomes 2x squared plus 1, which is something you will learn how to do that in Algebra 2, and it's so important that you'll spend, you know, several weeks on that in Algebra 2, and then when you go to college algebra, we spend several more weeks on it. Okay, so it's very important. But I show that because we're trying to draw a compare. I'm trying to open your eyes to what we're doing now is going to be beneficial and useful to you beyond this course. Okay, so let's do an example. Let's see kind of how this is all done. I think it's a good idea as you're doing these, and this is, you know, the case regardless of how many compositions you're doing, even if you're just doing a traditional singular transformation. I think it's nice to have the rules next to you because at some point you don't want to have to draw pictures with all these things, okay? And you're going to want to just apply these rules that I have up there on the whiteboard, and like I said, are in your email, because that's just going to make things so much more efficient for you. And I don't know why am I trying to get. And I'm going to start with, I'm going to use just some small values here for my ordered pair. So I'm going to go 2, 1. call that A. Let's put B at, let's go 4, -1. And 5, let's go 5, 3 for C. So all right, so we're going to start with that as our pre-image. Okay. And I want to do the following. I want to take a translation of, let's just go 2, -1, composed with, let's just do a rotation of 180 degrees of triangle ABC. So that is our pre-image. Okay. If we were going to rewrite that without that dot in there, we would write it this way. Okay. So either way you're going to view it, you're going to either work from the right to the left, or here you're going to work from the inside out. So those two things are the same, and we're going to do that first. So here's where it becomes useful to knowing or to have in our mind what our rules are for transformations. Okay, because we're going to conduct a 180-degree rotation, which if we know our rules, that becomes the opposite of A, opposite of B, right? So we should be able to quickly transform these points. So what is A going to turn into? -2, -1, right? Okay. What is B going to turn into? Yeah, -4, 1. All we're doing here is we're just negating both the x's and the y's, right? So a negative, if I negate a negative, it becomes positive, right? So B becomes -4, +1. And C is going to go to -5, -3. So I'm going to call that A prime. So it was -2, -1. B prime is at -4, 1, and C prime -5, -3. All right. So that, would you agree, is that's just what we did the last couple days, right? Just applying a rotation to a pre-image. So now, once I've done this stuff in blue, okay, that now becomes triangle A prime, B prime, C prime. So wipe that away. And now what is left over? Still this translation of 2, -1, right? Is that going to make sense to everyone? Now a translation, remember our rule for a translation, if this is like M and that's N of A comma B, okay, all you have to do is you take your A value, you add to it M, you take your B value, you add to it N, right? Okay, so all I'm doing is taking my ordered pairs here, and I'm adding 2 to the x's, and I'm adding -1 to the y's, right? So if I look at A prime, add 2 to the x, and you get what? 0. Add -1 to the y, what do you get? -2. So that point is going to go right there, okay? So we'll call that A double prime, located at 0, -2. Okay? We're going to go to B, add 2 to that, gives you -2, right? Add -1 to that, and it gives you 0, correct? So negative 2, 0. My mouse is having some issues. So B double prime, negative 2, comma, 0. And now C double prime, add 2 to your negative 5. So that would give you a negative 3. And then add negative 1 to that, so it would give you negative 4. So we're going to go left 3, and then down 4. And that's going to be C double prime, negative, negative 3, negative 4. And then I would connect those. And that black image, that black triangle, is the final image of that composition. That's the answer that we're looking for. Okay. So you see that this blue one, I can drag it. Okay, actually I can't, because it doesn't have a rotation tool on here to rotate it. But this blue one has been rotated to become the red one, and then the red one has been shifted to the right and slid down. Okay. If we use GeoGebra to verify this, which this is, I keep showing GeoGebra because I want you to use it. I want you to verify things. I don't want you to use it to get your answers. Does that make sense? Okay? Because that's circumventing the whole learning process. Okay? I want you to use it to make sure that your answer that you've created are correct. Which is, it's a hard thing to fight, because in the event of just trying to get the grade and get the answer, a lot of people just use it without kind of worrying about doing the work. Try to avoid doing that. All right, so that's that image, right? Okay, and you see the points that we started with. Okay, now I'm going to rotate this around 0, 0. Okay, we said rotate, what do we do, 180 degrees? So I'm going to rotate that shape around that 180 degrees. Does it matter clockwise or counterclockwise? Not if I'm doing 180. Okay, so I do that. Okay, now I need to add, you don't need to know why I'm doing this. It's just the way GeoGebra allows this to happen. We did 2, negative 1 as our translation, right? So I need a tool to allow GeoGebra to be able to take that point and move it to the right 2 and down 1, and vectors are that tool. And when we're done here in a little bit, I'll explain to you where we use this stuff and where a lot of you are currently using it when you're playing your game right now, Cameron. So now I'm going to take this shape, okay, and I'm going to translate it by vector u, okay, and you see that it gives me that one, okay. So I want to make that blue, and that, if you think about it, if you make the comparison, is that exactly the same type of thing that we got going on here, what we did by hand here, right? If you look at these points, negative 3, negative 4, 0, negative 2, negative 2, 0, come over here for your double primes. Those should be mimicked in GeoGebra. Is that all right with everybody? Okay. Now I'm going to do, you don't have to write this down, but I want you to see something here, which is very, 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 very important for compositions. I'm going to take that image and I'm going to put it on another graph. Okay, so we're going to start off with this image, which is the same as this one, right? Okay, now I am going to do the translation first. So I'm going to take that image and I'm going to translate by that again. Looks like I need to put that in here to do it. To the right 2, and then down 1, right? All right, so I'm going to take this image, translate that first, so I get that, right? Now I'm going to take that and rotate that 180 degrees. I need 0, 0 again. All right, so that rotated around there, 180 degrees, gives me this image, okay? If I look at graph 1 and graph 2, are the blue shapes the same? No, okay? This position here is different than that position, right? Okay, now they do look as though, if I could take this one off and put it over here, they do look like they'd be congruent, right? Which they should be. All we did was rigid motions here, right? Okay. Okay, so what I want you to understand here is that this composition on the left, this composition was looked like that, okay? The composition that I did over here would have looked like that by hand, okay? So in this one, we did the rotation first, right? In this one, we did the translation first. Were the results of these two compositions, even though the individual components are the same, are the results the same? No. So these two things are not equal, okay? Now I'm going to ask you what that means. And let's go back to answer this question. Let's go back to 8th grade, 7th grade, maybe 9th grade math. If I do this, I get 5, right? If I do this, I get 5, right? If I do this, I get 6, right? If I do this, I get 6. But if I do this, I don't get the same values, correct? Or if I do this, I don't get the same values. So these operations, addition and multiplication, you remember what the property was that we said about these two things that allowed this ordering or movement to occur? That these two operations, subtraction, division, did not have. Starts with a C. I heard it. What'd you say? Yes. That's weird. You did it twice. All right. Compositions of transformations are not commutative. Okay? Meaning that the order that we conduct them is extremely important. Okay? 2 plus 3, 3 plus 2. That didn't matter, the order, right? Meaning that you can move them around. So the root word commute means to move, right? Okay? So I can move 2 and 3's position and still get the result of 5. If I do my translation and my reflection or my rotation and I commute them, I do not get the same final product. All right? There are some transformations that are commutative, but collectively, as an overall group, they are not. All right? That's a very, very important property to know about composition of transformations. That'll be useful when you get into algebra as well. There are some, though, that are okay. Let's say, for instance, I start with A at, let's just say 3, 2. Okay? Let's reflect that across the line. Let's just go reflection on the y-axis, and then composed with reflection on the x-axis of just point A. So reading this backwards from the right to left, we're going to do that first, right? Reflect on the x-axis. Where's that going to take A? So reflect across the x-axis. Take it right there, isn't it? Okay, so let's call that A prime. Now, once I've done that, so this gives me A prime, now I'm going to do this with A prime. So what's the reflection across the y-axis? Where's that going to take it? -3, -2. Okay, so that's A double prime. That is that composition of transformations conducted on A. Okay, let's do this. Let's flip-flop it. Let's say we're going to do the x-axis first, composed. I guess writing it, we'll say x-axis first, but when we actually do this, we're going to work from the right to the left, so we'll do this one first. So let's take A and reflect on the y-axis. So where's that going to take it? -3, 2. So now that would be A prime, if we're doing this red rule. And now do that reflection. Where's that going to take it? So are those two equal? Yes. So that's the situation. A lot of, when you reflect, you piggyback reflections off one another. A lot of times they do end up being commutative. But we always want to make sure we can't just holistically say every single set of compositions is commutative. Okay. Now, is there a better way of writing this? If that's 3, 2, and this became -3, -2, if this is so let's assume that this is our A comma B, right? How would you write this if that was A comma B? -A, -B, right? Is there a rule over here on the whiteboard that says if you start with A comma B and you get -A comma -B? So a rotation of 180 degrees. So we find out that a rotation of 180 degrees of A is identical to that composition of those reflections. Okay? And that's a common question to be asked. If I've conducted these multiple compositions, can you provide a transformation that would have taken A straight, or your pre-image, straight to your final image without having to go through the kind of middleman images? Does that kind of make sense? Okay. So that hopefully maybe allows you to kind of maybe finish up those assignments. I know Chandler had a question about the last two. Is it the last two on the assignment that was due today or the assignment that's due next week? Today? Okay, so tell you what, all assignments, I will open all assignments up and I'll give similar exercises until Tuesday. Okay. Right. So and actually, let's open them up. I'll open them up until Wednesday, so we can actually talk about it on Tuesday. Okay. You guys have a great 4-day weekend.
You too. Have a good time.
Thank you. Thank you.